Hello students, welcome to Learn with JJ Academy. In today's video we are going to see Laplace transform, one of the very important topic of engineering mathematics. Laplace transform is invented by Pierre-Simon Laplace in 17th century. In 1718, the Laplace transform invented by Pierre Laplace. Its main formula is Laplace f of t is equal to integration of limit 0 to infinity e raised to minus st f of t dt. This is the main formula of Laplace transform. Laplace transform mainly used, or its applications are mainly used in control system, electrical circuits, signal processing and differential equation. This method is mostly used to transform time domain to S domain. Time domain to S domain. If you have to convert any entity, that time we use Laplace transform. Mostly in electric circuits or control systems or signal processing, mostly Laplace transform we used. So these are some standard formulas of Laplace transform, like derivative and integration. We have 10 formulas of Laplace transform. Okay, so the main formula is Laplace of k. The first formula is Laplace of k. You can see here I have shown by diagram also. This is a constant diagram of any constant value will be here. So Laplace of k is k by s. K means any constant value. Means for example Laplace of 4. Laplace of 4 will be 4 upon s. Laplace of 14 will be 14 upon s. Laplace of 140 will be 140 upon s. Means if we have to find Laplace of any constant, what you have to do? You have to just divide that value by s. That will be Laplace of k. Second is e raised to at. Second formula is Laplace of e raised to at. You can see here I'm shown by graph also. This is the e raised to at graph. Okay, so Laplace of e raised to at is 1 upon s minus a, where a means any constant value. Where a means any constant value. For example, suppose I have to find Laplace of e raised to 3t. So the Laplace of e raised to 3t will be 1 over s minus 3. You have to just replace a by 3. Okay, so e raised to at is equal to 1 over s minus a, and e raised to minus at, formula number 3. You can see here, if positive sign is here, e raised to at, that time we consider 1 over s minus a. But if e raised to minus at would be here, that time you have to consider plus term, means 1 upon s plus a. Opposite sign you have to consider. Okay, means for example, suppose you have to find Laplace of e raised to minus 2t. Okay, so just replace a by minus 2. So e raised to minus 2t Laplace will be 1 upon s plus 2. If minus sign is here, you have to consider Laplace in positive sign. If plus sign is there, then you have to consider Laplace in negative sign. Okay, remember these formulas. Formula number 4, sin at. The graph of sine curve is look like this. Okay, so Laplace of sin at is a over s square plus a square, where a means any constant value. Okay, for example, suppose I have to find Laplace of sine 3t. Suppose I have to find Laplace of sine 3t. So what you have to do? You have to just replace a by 3. So you will get 3 over s square plus 3 square. You have to just replace a by 3. Okay, Laplace of sine phi t will be 5 upon s square plus 5 square, in this way. Then formula number 5 is sin h at. You can see here formula number 4 and 5 are same. Sin at is a trigonometry term and sin h at is a hyperbolic term. So the Laplace of sin h at is a upon s square minus a square. So you can see here both the formulas are same, but for trigonometry sine term you have to consider plus term in denominator, and for hyperbolic sine term you have to consider minus term in denominator. Okay, remember this. Formula number 6, cos at. Laplace of cos at is s upon s square plus a square. You can see here formula number 4 and formula number 5. Formula 4 and formula number 6. If sine term is there, you have to consider a term in numerator, and if cos term is there, you have to consider s term in numerator, and denominator in both the case are same, s square plus a square. Remember this. Okay, so the Laplace of cos 2t will be s upon s square plus 2 square. Okay, like this. Similarly, formula number 7, formula number 6 and 7 are same. Cos at is a trigonometry term and cos h at is a hyperbolic term. Both the formulas are also same, means in Laplace of cos at is s upon s square plus a square, and Laplace of cos h at is s upon s square minus s square, same as sine term. So in trigonometry, you have to consider plus in denominator, and in hyperbolic, you have to consider minus in denominator. Remember this, okay? Then formula number 8, Laplace of t raised to n. So you can see here, there are two formulas for t raised to n. You can see here, there are two formulas, formula number 8 and formula number 9, right? So what you have to do, how will you identify in exam? Means which formula you have to apply. Always remember formula number 8. When we apply formula number 8, when n is a positive integer, okay? When n is a positive integer. And formula number 9 when we use when n is a fractional number. When n is a fractional number. Fractional number means 1 by 2, 3 by 2, 5 by 2, and so on. So formula number 8, you have to find Laplace of t raised to n. So the Laplace of t raised to n is n factorial upon s raised to n plus 1, okay, where n means power, okay. For example, if suppose I have to find Laplace of t raised to 4, so the Laplace of t raised to 4 will be 4 factorial upon s raised to 4 plus 1, that is 5, s raised to 5. Formula number 9, when they will give you Laplace of t raised to 3 by 2, okay. So you can see here power is fractional number here. That time we use this formula. So you can see here formula number 8 and 9, denominator is same, s raised to n plus 1, only numerator is different here. So this symbol is called as a gamma function, okay. This symbol is called as a gamma function. So the formula is Laplace of t raised to n is equal to gamma n plus 1 upon s raised to n plus 1. When you will use this formula, when n is a fractional number they will give you, okay. And last formula number 10, Laplace of ERF. ERF means what? Error function. Laplace of error function of root t is 1 upon s into root s plus 1. This is a standard formula. Anyhow, you have to by heart this, okay. We don't have any option. So remember, there's all formulas, and by heart there's 10 formulas. If you remember all these formulas, then you can solve any equation of Laplace transform, okay. So let's see some questions on this topic so that your topic will be clear. So the heading is find the Laplace transform of following functions. We have to find Laplace transform of following function. So already we have solved some questions on derivative and integration. So we know that when this kind of equation will be given to you, what we do first, we keep constant outside and only function we keep inside, and we differentiate or integrate. Same procedure you have to follow in Laplace also. What you have to do, you have to keep constant term outside, means 4 is constant here, keep it outside and put Laplace separately. So 4 outside Laplace of sine 2t, okay, plus again 3 constant, keep it outside, Laplace of cos phi t. Is it clear? What you have to do, you have to keep constant term outside and you have to apply Laplace to both the terms separately. Now 4 keep it as it is in bracket. Now we have Laplace of all terms like sine 2t. Laplace of sine 2t is 2 upon s square plus 2 square, right? A upon a square plus a square. Here a means 2, okay? Plus 3 keep it as it is. Apply Laplace of cos phi t formula. So Laplace of cos a t is s upon a square plus a square. So Laplace of cos phi t will be s upon a square plus phi square, okay. And finally just simplify this, means multiply 4 inside. So 4 times 2 will be 8 divided by s square plus 2 square, or you can write 4 also, and plus 3 times s will be 3s divided by s square plus either phi square you can write or 25, okay. In this way you can solve any equation of Laplace transform. Let's see question number 2. In question number 2, again same, they have given 3 terms and plus minus sign in between them. So what I am doing first, I am just applying Laplace to each term separately. So 5 Laplace of t raised to 4 minus 3 constant, keep it outside, Laplace of sine t, and plus, now you can see only constant term is there, so you have to keep this inside, Laplace of 6, okay. So now 5 in bracket Laplace of t raised to 4, formula number 8, t raised to n, okay. So here n is positive integer, so what I am doing, n factorial means 4 factorial upon s raised to 4 plus 1, that is 5, okay, minus 3 Laplace of sine t. Here a means 1, okay, so 1 upon s square plus 1, 1 upon s square plus 1, and plus Laplace of k is k by s, so Laplace of 6 will be 6 by s. So 4 factorial means 24, 24 times 5 will be 120, 120 upon s raised to 5 minus 3 times 1 will be 3 upon s square plus 1 and plus 6 over s. This will be your final answer. Let's see question number 3. In question number 3 you can see they have given bracket square, okay, so what you have to do initially you should know a plus b bracket square formula. So the formula is a square plus 2ab plus b square, okay. You can't directly find Laplace of this equation. Initially you have to simplify this equation first. So what I am doing, I am just expanding this equation. So t square square will be t raised to 4 plus 2 into multiplication of two terms means 2 into 3t square will be 6t square and plus second term square 3 square will be 9. Now apply Laplace to each term separately. So Laplace of t raised to 4 plus 6 constant, keep it outside, Laplace of t square and plus 9 is a single term, so keep it inside. So t raised to 4 Laplace will be, already we have seen here, 4 factorial upon s raised to 5. 4 factorial means 24 upon s raised to 4 plus 1 is s raised to 5 plus 6. T square Laplace will be 2 factorial means 2 upon s raised to 2 plus 1 will be 3 and plus Laplace of 9 will be 9 by s, okay. So in this way you can find Laplace of this kind of question. Now in question number 4 they have mentioned Laplace of sine square t, okay. You can't directly find Laplace of sine square t, okay. So for that you have to use trigonometry formula. So we have a formula, the formula is sine square theta is equal to 1 minus cos 2 theta divided by 2, okay. So what you have to do first here, you have to convert this term sine square t into this term. So what I am doing, I am taking 1 by 2 constant outside, Laplace of 1 minus cos 2t, apply formula in t form, okay. So instead of sine square t I directly apply this formula, okay. And now 1 by 2 in bracket Laplace of 1 is 1 by s and minus Laplace of cos 2t will be s upon s square plus 2 square, that is 4, okay. Or you can multiply 1 by 2 inside also, no way, okay. Similarly cos square 2t, like sine square theta we have formula of cos square theta also, and the formula of cos square theta is same, 1 plus cos 2 theta divided by 2, but in cos square formula you have to take plus sign in between two terms, and in sine square formula you have to take minus sign. Both the formulas same, but difference is sign in only. So Laplace of cos square 2t, so I can directly apply this formula. So the formula will be 1 plus, now you can see here for theta we have considered a 2 theta, so for 2t you have to consider its double angle, that is cos 4t, and divided by 2 will be as it is, okay. If the angle is 2t you have to consider 4t, if the angle would be 3t then we would have considered 6t, remember this. Now again same denominator 2, keep it outside, so 1 by 2 into Laplace of 1 plus cos 4t, okay. So 1 by 2 in bracket Laplace of 1, apply the formula 1 by s plus Laplace of cos 4t s upon s square plus 4 square, okay. This will be your final answer, okay. I hope all the questions are clear, okay. And the last question is again same, you can see here, always remember when they will give you bracket square term, that time you have to use expansion formula, a plus b bracket square formula, okay, remember this. So we have a plus b bracket square formula also, a square plus 2ab plus b square, so apply here. So Laplace of, here you will get first term square, that is sine square 2t plus 2 into multiplication of two terms, so sine 2t into cos 2t and plus second term square, that is cos square 2t, okay. Now we know this formula also. You have to remember there's two formulas. That first formula is sine square theta plus cos square theta is equal to 1. I know all students know this formula. This is the very important formula of trigonometry. Sine square theta plus cos square theta is equal to 1. And we have one more formula, sine 2 theta is equal to 2 sine theta into cos theta. Okay, you have to use these two formulas here. So what I'm doing, you can see here, Laplace of sine square t and first term and third term, sine square 2t plus cos square 2t will become 1. Okay, I apply first formula, sine square theta plus cos square theta. Here theta means 2t. Okay, and for middle term, 2 sine theta into cos theta. So 2 sine theta into cos theta is equal to what? Sine 2 theta. We have formula. So here directly I can write 2 sine 2t into cos 2t will be sine 4t. Okay, if angle is 2t, so you have to consider its double angle, that is 4t. Okay, and then you know directly apply the formula. So Laplace of 1 is 1 by s and plus Laplace of sine 4t will be 4 upon s square plus 4 square. Okay, so to solve the questions on Laplace transform, you have to remember trigonometry formula also. Okay, if you by heart all trigonometry formulas also, then you can solve any equation of Laplace transform. Okay, I hope Laplace transform concept is clear. Okay, in next video I'm going to explain you the properties of Laplace transform, multiplication by e raised to at, multiplication by t, and division by t. Okay, but to get notification you have to subscribe our channel. Okay, so don't forget to subscribe, like and share our channel. Okay, see you in next lecture. Till then, take care. Bye bye.